Welcome to the Zetectics Torque Tool Setup and Calibration video series. This part will cover using the auto calibration software feature. Before starting the calibration, the settings should be checked. A number of analyzer types are selectable. If your analyzer isn't in the list, you should use the manual option. Ensure the baud rate matches that of the analyzer. Set the target torque as the maximum you would like the tool to operate at. Typically, it is good practice to add 10% as long as the maximum tool rating is not exceeded. Ensure the analyzer units matches that set on the analyzer. Check the tool label for maximum tool pressure. For a Zetectics tool, this is 160 bar. The calibration will abort if this value is exceeded. If the pressure sensor has been scaled for PSI, ensure that the pressure and unit selection matches here. For example, 160 bar equals 2320 psi. The pressure valve control can be scaled in percentage or to match the analyzer units. It is important to note that this scaling is for indication only. The calibration is for the torque feedback against the analyzer. There are 3 calibration methods. It is advised to use SMART. This will allow the setting of the number of calibration steps, with 8 being the minimum. The torque application dictates which order the valves are operated in. This should match your intended operation order. Pressure before flow is recommended for best consistency. Setting the pressure valve first allows the operator to see how much pressure will be applied to the tool, as seen in the function tests. Finally, ensure that the correct serial port is selected for the analyzer. All other settings should be left unless advised otherwise by Zetectics. Return to the operating page. Start the tool calibration using the button on the operating page. The calibrator will display a series of pages in a pop-up window. The first page confirms the target torque. The second page asks the user for details of the tool to be calibrated. The data input here will be visible on the calibration record PDF that can be produced after completion. You cannot proceed to the next page until the analyzer is recognised. Ensure it is turned on and plugged into the correct COM port. The third page is for inputting the details of the analyzer. Again, these will be shown on the calibration report, so ensure they are accurate. The fourth page gives the user the option to not update the valve and sensor scaling after the calibration. This is set to update by default and should not be changed under normal circumstances. The fifth page presents an overview of the calibration that is about to be performed. Check the details are correct and abort if not. The sixth page instructs the user to attach the analyzer bucket and nudge the tool to take up the slack. The analyzer should only be zeroed before it is fitted to the tool and should always be removed when zeroing after the calibration. Nudge the tool, monitoring the analyzer for a spike in torque reading. Once the slack has been taken, proceed to the final page. Press OK to start the calibration. The software will take over control of the tool. A stop button is available to abort the calibration at any point. The calibration will aim for the target torque in the number of steps configured in the setup. The process will stop when the calibration conditions are met or if the maximum pressure is exceeded. When the process is complete, a box will appear. Pressing OK grants control back to the user. Pressing forward will display the calculated error between the torque tool and the analyzer. The next page tells the user where the calibration file has been stored. This is in the same location as the setup file. Pressing forward again will exit the calibration and present a message prompting the user to save the setup file. If the setup file is not saved at this point or before the software is closed, then all settings will be reset. Give the setup file a relatable name, usually indicating the type of tool and calibration performed. It is common to perform both high and low gear calibrations and have a separate setup file that can be switched between. A PDF calibration report can now be produced. Return to the Torque Tool Calibrator setup page and click Open Calibration File Analyzer. Click Read File and navigate to the calibration file. A number of graphs can be viewed, as well as the contents of the file, on the left hand side. Go to the Report tab, select Include Calibration Data to see a table of torque versus pressure on the report. If Open Report is ticked, then the file will open in the default PDF reader when it has been created. Click Create Report and choose where to save and what to name the file. The report will contain all the setup and equipment details entered by the operator. The scale values for the valve and sensor are there so they can be used for comparison before future operation. There will be a graph showing valve drive versus analyzer torque. The valve drive is an unscaled value. There will also be a repeat of the transducer error chart with more detail. If calibration data was selected, this will be shown on the second page. This shows each calibration step with analyzer torque and pressure being measured values. Demand torque is a calculated value based on the scaling produced by the calibration. If percentage was selected for torque demand units, then this will be reflected in this column. A verification check should be performed after a calibration. The calibration report can be used as an indication of what torque may be achieved based on the applied pressure. It should be noted that the calibration runs at 100% flow and in a clockwise direction. The bucket should be removed so the analyzer and torque feedback can be zeroed if necessary. Remember to nudge the tool to remove any slack and ensure that zero is not pressed again until the bucket is removed. Operate the valves in the same order as the calibration was performed, ensuring that they are zeroed between tests. Compare the feedback in the software to the analyzer reading. Demonstrated next is an exaggerated example of a common error when operating. Notice how the flow slider jumps to the position clicked, then is dragged to 100%. As a result, the achieved torque is much less for the same pressure applied. The next example shows approximately 50% flow applied, and again less torque is achieved. In both of these examples, the torque feedback is comparable to the analyzer. The reason for showing these examples is to reiterate that the calibration is for the torque feedback only. Numerous variables prevent the torque demand being accurately calibrated for consistent results. This applies to all torque tool types. This is also why the torque tool manual has the displayed statement. Operating in this method helps the user prevent overshooting the required torque. Carrying on increasing the pressure steps, compare feedback against the analyzer until the target torque is achieved. When the tool has been calibrated to the exact target torque figure, it may not be achievable after the calibration. If this occurs, then the maximum torque demand can be adjusted to allow more pressure to be applied to the tool. When increasing the demand above the maximum, it is even more important to check the pressure value before opening the flow valve. Here we see that the pressure is less than that applied to achieve 2,730 Nm during the calibration. As expected, we do not achieve the required torque. Increasing the demand, we can see the pressure increasing also. Now, when we open the flow valve, we have achieved a higher torque value. Increasing the pressure again, we will attempt to achieve the target torque value. In this instance, it requires 50 Nm extra demand to achieve our required torque. This will vary depending on the tool, control system, and HPU being used, amongst other variables. As always, the feedback is accurate compared to the analyzer, which means we have achieved a successful calibration and verification. This concludes the torque tool setup and calibration video series. For any further support, please use the details shown.